It must not be forgotten that all effects of motion are expressed in their plus and minus opposites. All plus effects of motion have been clearly defined as generative, contractive effects, and all minus effects have been defined as radiative, expansive effects. It must not be forgotten that all mass is either preponderantly charging or adding to, or it is preponderantly discharging or subtracting from. For this reason, all effects of motion in mass must be measured in both of their opposite dimensions, their plus and their minus dimension. The plus dimension shall herein be called the contraction dimension. The contraction dimension is the charging dimension of the electropositive force, which winds the cosmic clock. The minus dimension shall herein be called the expansion dimension. The expansion dimension is the discharging dimension of the electronegative force, which unwinds the cosmic clock. Now there's another chart here. It's called Universal Ratios, Universal Mathematics, and I'll read what it says about the ratios on this page. All dimensions are pressure dimensions. All dimensions simultaneously expand and contract in opposite directions of the same ratio. With distance, plane, and area dimensions given, any planet or satellite in the solar system can be measured in all of its dimensions by contracting or expanding the standard units of the planet in universal ratios. Any relative dimension in any position within a mass can be determined by applying the laws of universal ratios to that position. The laws. Expansion pressure is in direct ratio to the square of the distance, degree, area, plane, orbit, or time unit, and to the cube of the volume. Contraction pressure is in inverse ratio to the square of the distance, degree, area, plane, orbit, or time unit, and to the cube of the volume. Every mass in the universe occupies a measurable potential position. The formula of the locked potentials in universal ratios. At the bottom of this chart it says, dimension chart number 2, nature divides all of her expressions of energy into octaves and tones of equal constants of unequal dimensions. The dimensional relations of octaves and tones vary in ratios which are absolute and universal. To illustrate, back to the words on the page, to illustrate, consider an expanded mass at B or double its diameter at A. Assume A to be 60 million miles from the Sun. At B it would be twice its former distance, or 120 million miles. At B, its expansion temperature dimension, as registered in cold, would have increased by 8 times, just as its volume would have increased by the cube of its former volume. At B, its contraction temperature dimension, as registered in heat, would have decreased to 1/8, because the heat units would have become spread over 8 times its former space. At B rotation, the speed-time expansion dimension would be the square in direct ratio of the position at A. Conversely, at B revolution, the speed-time contraction dimension would be the square in inverse ratio of the position at A. Just so with all of its pressure dimensions and effects, from density to ionization, and from ionization to time, sex, or crystallization. The charts herein printed clearly show the tonal relations of all potential positions in the wave. It has heretofore been written that all effects of motion are expressed in 7 equal tones of 4 units. The 7 tones of the universal constant are consecutively removed one from the other, the square of the distance to the next highest potential. The energy of each of the 4 units is exactly equal to that of each of the others. 1 plus, for example, is removed from 2 plus by the square of the distance to 3 plus, which is the next highest potential. By a study of the accompanying dimension charts, one can readily see that any change in the expansion or contraction dimension of any effective motion is in either direct ratio or inverse ratio to the square of the distance, area, or plane dimensions, or to the cube of the volume dimension. All dimensions are pressure dimensions. All dimensions simultaneously expand and contract in opposite directions of the same ratio. All effects of motion are measurable either in distance, area, or volume ratios. Also, all are measurable in both the ratios of contraction and of expansion pressure. The ratios of contraction and of expansion pressure shall herein be termed the universal ratios. Expansion pressure is in direct ratio to the square of the distance, area, plane or orbit or time unit, and to the cube of the volume. Contraction pressure is in inverse ratio to the square of the distance, area, plane, orbit, or time unit, and to the cube of the volume. Every mass in the universe occupies a measurable potential position. With distance, plane, and area dimensions given, any planet or satellite in the solar system can be measured in all of its dimensions by contracting or expanding the standard units of this planet in universal ratios as a comparison. Let us consider some of these effects. We know the diameter of Jupiter, its plane of orbit, and its distance from the Sun. From these we can easily determine its potential position and rotation period. Let us roughly demonstrate the principle and check the result by our actual knowledge of its rotation period. For simplicity, let us bring Jupiter back to our known potential position and give it a standard unit of rotation from our knowledge of our own position. By calculating an inverse universal ratio, it is an easy matter to determine that the diameter of Jupiter was about 17,000 miles when it was in the Earth's potential position. With more than twice the Earth's circumference and rotating at the speed of the swirling spiral discharging ecliptic area of this particular part of the solar vortex which we occupy, it would take more than twice the time the Earth would take to complete its turning. Roughly, its day would be about 40 hours. That being ascertained, its rotation period, if it were in the Earth's plane, would be about 11 hours. Allowing the difference of about an hour in greater speed for the slight difference in plane, its rotation, if precisely calculated, would check with the known rotation of 9 hours and 55 minutes. In calculating Mars' rotation, its difference of plane would retard rotation so appreciably that its day would be lengthened by about 9 hours more than it would be if it were in the Earth's plane. For another example, let us calculate what the rotation of the Earth will be when it is 360 billion miles from the Sun. Let us assume an even 24 hours as its present standard unit, and even 8,000 miles as its diameter, and 90 million miles its distance from the Sun, ignoring the fractions and loss by radiation. At 180 million miles, its diameter will be 16,000 miles, and at 360 million miles, it must be 32,000 miles. At 180 million miles, its day must be 12 hours, and at 360 million miles, it would be 6 hours. When in this position, its density would be about 1/64th of hours, and on its surface, iron would melt at about 22 degrees. It is hard to realize that molten iron